Hello students, so today we will start 10th standard physics chapter called electricity. This is very important chapter not only from 10th examination point of view but its continuation in 12th standard would form substantial amount of portion of 12th standard physics. Also from practical point of view. So pay attention and try to understand the concepts very clearly. Now this electricity is of two types. One is called static electricity and other is called current electricity. You have studied about static electricity in the 9th standard. That if we take a glass rod and if we rub it with silk cloth, then the glass rod will attract pieces of paper. But before rubbing, it was not showing this property. Similarly, if we take ebonite rod and rub with a woolen cloth, it will also attract pieces of paper. Means investigations reveal that some charges have got developed in glass rod and ebonite rod. But when we take two glass rods rubbed with silk cloth near one another, they repel. Similarly, if we take two ebonite rods rubbed with woolen cloth and bring near one another, they will repel. So if I take two rods, these are two glass rods, and if I am bringing near one another, there will be a force of repulsion. In this direction, this rod will try to move in this direction. But if I take a glass rod and ebonite rod and bring near one another, they will attract. So, and other experiments were also done, so they confirmed that like charges repel and unlike charges attract. Is it all right? Now at that point of time, structure of an atom was not known, but today we know the structure of an atom, and so we can explain why does this take place. Because an atom, you know, consists of a central nucleus in which there are protons which are positive charge and neutrons which are neutral charge. Outside, electrons are rotating which are negatively charged. Outside orbits, electrons are rotating which are negatively charged. Now the charge of one electron is equal to charge of one proton. Atom consists of number of protons equal to number of electrons. So total charge on an atom becomes 0. So we say atom is neutral. As matter consists of many atoms and all atoms are neutral, so matter is neutral. So similarly, glass rod and ebonite rod were neutral before rubbing. Then what happens when we rub? When we rub, then protons are in the nucleus. They cannot move out from the nucleus. But electrons, especially electrons which are in the outermost orbit, they are weakly held by the nucleus. So when we rub, some electrons move out from the atom and we say it becomes free and it goes to the other material. Like when we rub glass rod with silk cloth, then we say glass rod will become positive. So what does it mean? It means glass rod has lost some of its electrons to the silk cloth. So as glass rod has lost the electron, so its net charge will become positive because now some of the atoms are having more protons compared to electrons. Whereas ebonite rod has become negatively charged, ebonite rod has become negatively charged. So what does it mean? It means ebonite rod has gained electrons from the woolen cloth. So as ebonite rod has gained electrons, now it is having more electrons as compared to protons in some of their atoms, so it has become negatively charged. Is it all right? So the property of the charges is that they repel one another in case they are of same type. and they attract one another in case they are of opposite type. One is positive, other is negative, they will attract. Both are positive or both are negative, they will repel. So this is what we have studied in previous classes. And why these charges were stationary? Because those materials were insulators where charges cannot flow. Now, why charges flow in metals? Metals are called conductors. Conductor means materials in which charges can flow, because in conductors the are made up of metals, and those metals are having 1 or 2 electrons in the outermost orbit, which are weakly held by the nucleus. As they are weakly held by the nucleus, if we give some energy, if we heat the metal or give some energy through those electrons come out from the outermost orbit and wander in the material. So such electrons are called free electrons. And if we give a positive charge, electrons will get attracted towards that positive charge and they will move in a particular direction. Therefore, as the electrons move, we say they are conductors. So metals are good conductors, whereas non-metals are bad conductors, because non-metals have 6 or 7 or 5 electrons. So they share the electrons to complete their octet. So electrons cannot get emitted, except graphite, which is a form of a carbon, is a good conductor of electricity. Okay, about this we will be learning in detail later on. Now, what is 1 unit of electric charge? 1 unit of electric charge is called 1 coulomb. So 1 coulomb is 1 unit of electric charge. Like 1 unit of length is meter, similarly 1 unit of electric charge is 1 coulomb in SI system. What is 1 coulomb of charge? If we take 2 charge bodies having same amount of charges, and we are taking charge bodies having similar, means both positive or both negative, and in case they repel with a force of 9 into 10 raised to 9 Newton, then we say both bodies are having a charge of 1 coulomb. Okay, what is the distance between those bodies? It is 1 meter. Okay, so I have got 2 bodies. One body is here, one body is here. Both are having equal amount of charge. The distance between them is 1 meter. This is also positive charge, this is also positive charge. Now this is getting repelled by the force 9 into 10 raised to 9 Newton. This is also getting repelled by a force of 9 into 10 raised to 9 meter. So we say both the bodies are having charge of 1 coulomb. Now using this, we have found that charge of an electron is negative and its value is 1.6 into 10 raised to minus 19 coulomb. This you can remember also. Charge of an electron is 1.6 multiplied by 10 raised to minus 19 coulomb. As charge of proton is equal to charge of electron, so proton also carries the charge of this amount, but it is positive. Is it all right? In general, as I told you, metals are good conductors of electricity, and the materials which are not good conductors, they are called insulators, like wood. Wood is an insulator. Plastic, ebonite, mica, bakelite, porcelain, all such things are insulators. So through them we cannot pass electricity. Then there are certain alloys. Alloys like nichrome. Nichrome is made of nickel and chromium. Manganese, constantan, or others, all alloys. Their conductivity is less than of the metals. Like nichrome is made of nickel and chromium, but its conductivity is less than of nickel and chromium. They are used for making heating elements of electrical appliances and for some other purposes. We will be studying that in detail, but you can just now understand that alloys are having conductivity less than the metals of which they are made of. Okay, so they are good conductors, but conductivity is less compared to aluminium and silver. Silver is the best conductor. Then comes copper, then aluminium, and so on. Is it all right? So now we will start our chapter terms, technical terms of this chapter. There are electric current, potential difference, and resistance. These are three basic terms of this chapter. So try to understand them very carefully so that you understand. Now, electric current is very simple. How much charges flow through a cross section of the conductor? Rate of flow of charge. Rate means per second. As I told you in physics, always rate means per second. Now this is my wire. Okay, suppose this is the cross section. Circular is the cross section. This is the wire. This is length of the wire, and this is the cross section of the wire. So this is called area of cross section, and this is called length of the wire. Now, amount of electrons that are flowing from here, the same amount of electrons are coming out here. So, how many electrons are flowing per second? That is electric current. So, rate of flow of electric charge is electric current. Now, I have written here rate of flow of electric charge. But here I told you electrons, because in metals, as I told you, normally electrons flow as they are from free electrons. But in a liquid, in a solution, we may have ions. Ions also flow. We may have positive ion as well as negative ion, and they may flow. So that is also current. So electric current means rate of flow of electric charge through any cross section of the conductor. But in metals, we will be coming across only flow of electrons, because protons don't flow. But this is the general definition of current, rate of flow of electric charge through any cross section of the wire. Now, if positive charge is flowing in this diagram, if positive charge is flowing from, suppose, A to B, positive charge is flowing from A to B, I would say current, direction of the current is from A to B. But if electrons are flowing from A to B, so it means like positive charge is flowing from B to A. So the direction of flow of electron, a negative charge, is opposite to flow of charge. But the convention is that we always mention flow of positive charges. In which if I say the current is from A to B, it means positive charges are flowing from A to B. But in reality, in a metal, positive charge don't flow, means electrons are flowing from B to A. But I will always say the direction of flow of positive charges. Is it all right? So, if delta Q is the charge that has flown from A to B in how much time? In time delta T. Then delta Q upon delta T is the average current during this time delta T. If the current rate of flow of charges was not uniform, but in case it is uniform, then delta Q upon delta T is the current. Is it all right? So this is the first formula we have derived, that instead of delta we said, we can also say dq by dt, rate of flow of charge. So this is the first formula, current is equal to Q upon T. So this you should remember, first formula we have derived. Now charge is in coulomb, time is second. So coulomb per second, current is called ampere. So SI unit of current is ampere. So 1 ampere means 1 coulomb of charge is flowing per second through any cross section of the conductor. Is it all right? Now, this current is measured by using an instrument called ammeter. About construction of ammeter will be learning in 12th standard. Okay, I have now only learn ammeter measures the current, and it is connected in series. I will explain to you. What do we mean by conduction in series? Now, if one electron is having a charge of E, then 2 electrons will have a charge of 2E, 3 electrons will have a charge of 3E, so n electron will have a charge of Ne. So, by total charge Q is equal to n into E. If n electrons are flowing per second, means n into E charge is flowing per second. Okay. So, it means n into E charge is flowing per second. This is the second formula you should learn. Charge is equal to n into E, where E is charge of an electron, whose value I have told you is 1.6 multiplied by 10 raised to minus 19 coulomb. So, if my charge is 1, E is, then how many electrons are there? Then n would be equal to Q upon E. So, number of electrons that are flowing to get a charge of 1 would be 1 upon E. So, this I have calculated and I have got 6.25 into 10 raised to 18. So, these are the number of electrons that flow per second in a wire to have a current of 1 ampere, or to get 1 coulomb of charge is made up of 6.25 10 raised to 18 electrons. Okay. So, this two formula we have derived based upon. Now, let us do one small numerical so as to know the two use of the how to use the two formulae which we have derived so far. The question reads, how many electrons will pass through a lamp in 1 minute? So, time is given to be 1 minute. 1 minute means 60 seconds. Current is 300 milliampere. So, this will be 0.3 ampere because 1 milliampere 10 raised to minus 3 ampere. Now, we have to find how many electrons. So, to know number of electrons, we should first find the charge. So, I will use the formula Q is equal to IT. I know the current 0.3, I know time is 60. If I multiply, I get 18 coulomb. So, first we have calculated how much charge has flown in 1 minute. Now, I know 1 coulomb is 6.25 into 10 raised to 18 electron. So, if I multiply by this number, I will get the number of electrons in 18 coulomb. So, I will get this answer. So many electrons have flown in 1 minute. Is it all right? So, this is how we can do this numerical. Now, pay very attention. We are learning one very important term called potential. And second term, if you understand this, would be easier to understand. That is called PD. PD means potential difference. I will explain that later on. First, let us understand what is potential. Now, you see, you know, in case I am having a tank here and another tank here, and if I join these two tanks by a pipe, small diameter pipe, if here the level is more, here the level is less, due to this level difference, water will flow. The rate of flow of water would depend upon the level difference. Suppose this tank is also quite big, and after some time the level in both become equal, the flow rate will stop. So, for the water to flow, level is important, level difference is important. More the level difference, more is the flow rate. Similarly, in case I have got some water at 30 degrees Celsius and another water at 60 degrees Celsius, in case I join them, then the heat will get transferred from 60 to 30, not from 30 to 60. Now, the rate of flow of heat will depend upon this temperature difference. This is 30, this is 32. The transfer of heat will be at a very small rate, but this is 30, this is 80 degrees Celsius, the rate of flow of heat would be quite fast. So, temperature decides the rate of flow of heat from one body to other. level decides the rate of flow of water when two tanks are connected. Similarly, in case I have got this inclined plane, there is a ball I kept here, the ball will roll down. Now, more is the angle, the ball will roll down faster. So, similarly, in electricity, at what rate that electrons or charges move will depend upon what? Will depend upon some parameter. That parameter is called potential. As level, difference in level decides the flow rate of water when the two tanks are connected. Temperature difference decides that. So, similarly, potential difference will decide the rate of flow of charge. Now, to understand potential difference, first we should understand potential. So, potential is that property which will decide that charges should flow from which body to which body and at what rate. So, for that, consider I have got a body here positive charge, I have got another body here positive charge, I have got some body here negative charge. Now, I am asking if a body A is here, if this is a point A. So, due to this positive charge, this negative charge, at A, we say there is some electric field, there is some electric potential, because if I am taking this one positive charge, unit positive charge means 1 coulomb of charge. If I bring it at near to A, I find that it is getting repelled. So, means at point A, there is some positive potential, or there is some positive charge, you can say positive effect of the positive charge which is repelling this charge. If I remove all these charges, then I can easily bring positive charge from this point to this point. There is no repulsion, there is no force of repulsion. So, when I am bringing this charge towards A, I am experiencing a force, so I will have to do some work to bring this positive charge near to A. So, if my point is here, I will find that the magnitude of force is different now, because the value of potential here is different. So, as I move away, suppose from here if I bring towards A, this body is getting repelled, I have to do some work. If I take my positive unit test charge here, so the distance is more, so you will find that force of repulsion is less. If I go here, it will become further less. So, how we define, in case I am at infinity, very large distance, then the potential at that point would be 0 due to these charges. So, we say infinity, we assume that infinity is having 0 potential. So, at infinity there is no potential. So, if I bring some unit positive charge from infinity to A, at the point A, I have to do some work, because as I come nearer and nearer towards A, and A is having some potential due to these charges located around it, so I have to do work. Then amount of work that I have to do in bringing charge from infinity to the point A is suppose W, and if I am bringing a charge of magnitude Q, then W upon Q is called potential at A, V at A, because I am bringing the charge up to A. So, if I bring a charge of magnitude Q from infinity to the point A, amount of work done is W, then I say potential at A is W upon V, W upon Q. So, if I take Q is equal to 1, so that is what I started with. So, if I bring a unit positive charge, then my potential at A is the work done. So, potential at point A is amount of work that I am doing to bring a unit positive charge from infinity to point A. Now, let us come to the unit of V. W is measured in work done joule. This is measured in coulomb. So it is J C raised to minus 1 joule per coulomb. Instead of telling joule per coulomb, such long thing, this unit is called volt, is called VOLT, volt. What is 1 volt? 1 joule per coulomb. What is 1 joule per coulomb? What is 1 volt? It is the amount of work done in bringing unit positive charge from infinity to that point. Then whatever is the work done, it is that volt. So in case from infinity you are bringing a charge of 1 coulomb to A and work done is 4. So means the potential at A is 4 volt. Potential at A is 4 volt. So VA, if I say is 4 volt, what does it mean? It means the amount of work done in bringing unit positive charge from infinity to A is 4 volt. Now if I take a point here, some point here B, then you can see if I bring the charge from infinity to B, now B is farther away from the charges, so work done would be less. So suppose the work done is 3 volt, 3 joule. So if I bring a unit positive charge from infinity to B and the work done is 3 joule, so potential at B is 3 volt. And in short we write only V. Is it okay? So as I was telling you, difference. How do you calculate the difference? Like here the temperature was 30 degree, here the temperature 80 degree, you say temperature difference is 80 minus 30. If this level from some base, from this base, the level of this water is 5 meter, the water in this tank is 3 meter, the level difference is 2 meter. Similarly, if the voltage at A is 4 volt, at this point voltage is 4 volt and at point B it is 3 volt, the difference in voltage is called potential difference, PD. So that would be 4 volt. So that would be four volt minus 3 volt. So that will give you 1 volt. So potential difference between A and B. So that is written as VA minus VB. So I was explaining you that we have 2 points, A and another point is B. This is suppose infinity. If from infinity I bring a unit positive charge towards A, work done in bringing to A is 4 joule. So as a work done in bringing from infinity to B is 3 joule and I am bringing unit positive charge. So if work done is 4 joule, potential at A would be 4 volt. Potential at B would be 3 volt. So now what is PA minus PB? Potential at A minus potential at B would be 4 minus 3 would be 1 volt. Now what do we mean by that P potential difference between A and B is equal to 1 volt between A and B? What does it mean? The potential difference between A and B is 1 volt. Potential difference is written as PD. So I will say PD, potential difference between A and B is 1 volt. So what does it mean? What does this mean? It means that in case I move my unit positive charge from B to A, work done would be 1 joule. Because work done is independent of the path. So if I bring from infinity to A is 4, I have brought only up to B, so that is part of the way, and if I bring it further, I will have to do 1 joule of volt. So that is called potential difference between A and B will give me. So in case potential difference is equal to 1 volt, and if I want to move a charge of 2 coulomb, then what formula work done would be 2 joule, because for 1 joule, for 1 volt difference, it is 1 volt. 1 joule is the work done. For 2 joule of work, so potential difference has to be double, as we know. So what we can say, potential difference is equal to W upon Q. So if I am bringing double the quantity of charge, so I will have to do double the amount of work. So if PD is same, PD between A and B is suppose 2 volt, and work done I don't know, I am bringing a charge of 5 coulomb, so work done would be 2 into 5, 10 joule. So work done would be 10 joule. So this is the formula, potential difference is W upon Q. When we are bringing a charge from lower potential to higher potential, work done would be potential difference multiplied by Q, because potential difference is defined for unit charge. Is it all right? So this is the potential difference formula. So if these things are clear, then you have studied. Now important topic of electricity. Now you see, this is a battery. Battery supplies that potential difference. The bigger line indicates positive and the smaller line indicates negative. So this is at a higher potential compared to this. So now the current will flow always from positive, will come here, will come here. Current will flow through the ammeter, and then this is the conductor in which I want it for the current to flow. So the same current that is flowing through the ammeter will flow through the conductor, and after flowing it will come out, and it will, this is another resistance, this is called rheostat. Rheostat means I can adjust its resistance. So this is called variable resistance. So variable resistance is shown like this, or you can show like this. This is arrow. Okay. So I can, once I have adjusted this resistance, I have closed this switch, so this becomes a closed path. Always, whenever there is a closed path, then only current will flow. If the switch is open, the path is not closed, so current will not flow. Now current will flow from positive through the ammeter, through the conductor, through this part of the rheostat, through the switch towards the negative. So this is called, closed path is called circuit. Okay. Now I wanted to do experiment on this conductor, so I measured the current. So now ammeter and conductor, they are connected in line. So they are, we say ammeter is connected in series. I also want to measure the potential difference across this conductor between these 2 points. These are the conductors, end of the conductor. So from this end I am taking another wire and connected in parallel. So means, because now from here very small amount of current will flow to the voltmeter. To the voltmeter current flow that will flow is very negligible amount. So the current that was flowing through the conductor will continue to flow, and this will measure the potential difference across the conductor. So this is a voltmeter. Here I can read the voltage that is across the conductor, we say, and ammeter is connected in series. If I adjust this value of rheostat, bring it here or here, then you will see that ammeter and voltmeter readings will change. If I reduce the resistance, current will be more. I will explain that in the next session. Now here only I wanted to explain you what do we mean by ammeter in series and voltmeter in parallel. So when the same current that is flowing through the conductor flows through the ammeter, we say it is in series, so it is in line. And when we take a tapping from the ends of the conductor and connect a voltmeter. This is said to be connected in parallel. And the various symbols for the various circuit elements are given in the textbook. I think you can read and learn those symbols. Few symbols like you can see battery, this is a symbol, this one is called cell, and 2 or 3 or more are called battery. So this is a battery, this is a symbol for switch, this is a symbol for rheostat, this symbol for conductor, this is for ammeter, this is voltmeter. In ammeter and voltmeter, at the two ends it will be written positive and negative. A positive would be shown red and this will be shown black. So positive should be connected towards the positive. So battery, this is positive, so now positive is first, and for voltmeter this is positive and this is negative. So positive is connected to positive. Always current flows from positive to negative, as in conductor current is flowing in this direction. So means this is positive, this is negative. Okay, so these are the, I have explained you when do we mean connected in series or parallel. And if we go to this previous slide, now you can read the definition of potential difference. Potential difference between 2 points is equal to work done in moving unit positive charge. Moving unit positive from one point to other. So VA minus VB is W upon Q in case I am moving Q. And this is again joule per coulomb, so this is in volt. Always difference has the same unit of the two. I can subtract meters from meter. I can subtract kg from kg. I am subtracting volt from volt, so answer would be in volt. Is it alright? So here I written potentiometer is connected in voltmeter in parallel. So I explain to you what does it mean. Now in the next session I will explain to you about the next important term, resistance, and its law, which is known as Ohm's law. Thank you.